Hello, welcome everyone. Today we are doing circle theorem. This is part 2. We have already done 2 theorems and from third theorem I am teaching here in this lecture. But before that, if you want one-on-one live online sessions, if you want to book a demo, just drop us an email at akzsiacademy@gmail.com. If you want to access the worksheets that are available on Akzsi app, and link is already in the description box. So let me start. Third theorem deals with the cyclic quadrilateral. Cyclic quadrilateral, that means a quadrilateral whose all the endpoints are lying on the circumference of the circle. This kind of quadrilateral is called cyclic quadrilateral because all the vertices of this quadrilateral are lying on the circle. But suppose if a quadrilateral is like this, then it will not be a cyclic quadrilateral because 3 vertices are lying on the circumference, but the 4th one is inside the circle. Sometimes the kids do this mistake that they use the circle theorem thinking that this is a cyclic quadrilateral. You can't apply the theorem unless the quadrilateral is a cyclic quadrilateral. Theorem 3 says in a cyclic quadrilateral, the angles that are opposite to each other always add up to 180 degrees. So suppose if it's A, B, C, D, then angles that are opposite to each other, angle A and angle C are opposite to each other. So when I add them, it will give me 180 degrees. So angle A plus angle C is equals to 180 degrees. And similarly, angle B and angle D are opposite. So angle B plus angle D is equals to 180 degrees. So we can write theorem as in a cyclic quadrilateral, opposite angles always add up to 180 degrees. So suppose this is a quadrilateral. Let me name it A, B, C, D, and O is the center of circle. ABCD is a quadrilateral. I have just joined A and C to the center of the circle. Let me say that this one is X and this angle is Y. So angle ABC is X degrees, whereas angle ADC is Y degrees. Now, if we see the first theorem says the angle at the center is always twice the angle at the circumference if it subtends by the same arc. The arc A and C is subtending angle, which is this angle. And it is subtending arc angle at the circumference, which is Y. So arc AC is subtending Y on circumference. So I can say that angle at the center will be twice of it. So clearly this will become 2y. So angle AOC will become 2y by theorem 1. Similarly, this major arc. Previously I was talking about the minor arc, the smaller arc that was making an angle D at the circumference or Y at the circumference. Now if I see this one, this arc, the major arc, the larger portion that you can see, this arc is subtending B, angle ABC at the circumference. So angle ABC is equals to X degrees. Then what angle will it make at the center? This angle will be at the center. And this will be twice the angle at the circumference. That means this is 2x. So I can say then angle AOC is equals to 2x. That is reflex angle AOC is equals to 2x, same by theorem 1. Now clearly we know that this part is 2x and this part is 2y. And we know the angle, the total angle is always 360 degrees. So 2y plus 2x is equals to 360 degrees. Taking out 2s common, y plus x is equals to 360 degrees, or x plus y is equals to 180 degrees. What is angle x? It's angle ABC. And what is angle y? Angle DC. This is 180 degrees, and that we have to prove, right? That the opposite angles add up to 180 degrees. That's your theorem 3. And this is the proof of it. This is theorem 4. Theorem 4 says the angle at the circumference in a semicircle is always a right angle. This is a semicircle. Obviously, if it's a semicircle, so on this line, this is diameter of your circle, and at the center will be the center of the circle. It says the angle at the circumference in a semicircle is a right angle. That means this angle subtended by the semicircle will be a right angle. So if I name A, B, C, this will be 90 degrees. See, now let me see its proof. It's very easy to prove. Same, we have to use the theorem 1. We know that angle at the center is always twice at the circumference. If I talk about this arc AC, this arc AC is making 180 degrees at the center, clearly. So, what it will make at the circumference, angle ABC it is making at the circumference. And this will be always half at the center. So, half of 180 is 90 degrees. So, I can say angle AOC is equals to 180 degrees. So, this is the angle subtended by the arc AC at the center. And angle ABC is what? 180 by 2 by theorem 1. Angle ABC is angle subtended by AC at circumference, and this is always half at the center. Next theorem is theorem 5. Before that, what is a tangent? Tangent is a straight line that touches any curve. Doesn't matter it's a circle or a parabola, what kind of curve we have. But if that straight line is touching a curve only at one point, then we say that it is a tangent. Similarly, for this circle, if this is a circle and it's a straight line and it's touching at one point, it says that angle between a tangent and a radius is always 90 degrees. So angle between, this is a tangent and this is a radius, OB. An angle between them is 90 degrees. This is your theorem 5. Theorem 6 also deals with the tangent, but with a pair of tangents. It says if the two tangents and they are meeting at one point. These are two tangents. Let me name it A, B, C. So two tangents AB and BC. If they are meeting at one point, then the length of the chords will be equal. The length of the tangents will be equal. So which means AB will be equals to BC. So what we can say? Tangents let me see the proof of it. So first, let me join AC with the center. So A with O and C with O and join this one. Why I did so that I can have two triangles. Triangle 1 and triangle 2. So now I have triangle AOB, triangle AOB, and I have triangle BOC. Why I am doing this? Because I want to prove AB is equals to BC. I want to prove the lengths to be equal. If I want to prove that two lengths are equal, two angles are equal, the best way possible is to find two triangles and prove them congruent. This is the simplest way by which you can do. And if you are doing any question in circle, you have to either use the circle theorems or you have to use the properties of the triangle. That's all you have to do to prove or to find any angle, side or anything in a circle. So since I have divided into two triangles, now I have to prove these two triangles as congruent. First thing is, clearly I can say that these two angles are 90 degrees. We just studied the theorem 5, which says that the angle between the radius and the tangent is always 90 degrees. So this is 90 degree and this is 90 degree. So I can say angle OAB is equals to 90 degrees and angle OCB is equals to 90 degrees. That means they both are equal to each other. The next thing is AO and OC because they both are radius of the circle. So radius is always same. So I can say length AO is equals to length OC because they both are radius. And next is OB because this is a common chord. So OB is equals to BO because it's common chord. So by RHS rule, we can say that both the triangles are congruent. So by RHS, both triangles are congruent. And if both triangles are congruent, so by CPCT, I can say that the length AB is equals to CB and that we have to prove. That's it for today. And before going, again, I have to say that if you want to enroll yourself for one-on-one live online classes or for batch classes for GCSE, AS, A-levels or for KS3, KS2, KS1, just drop us an email, akzsiacademy@gmail.com. So that's it for today. Thank you. Stay tuned. Take care.